Hi guys, I'm back. This time I'm helping a plumber fit a boiler in a loft. I'm going to give him a hand putting it in the loft. And this install is a storage high performance combi. And they're fantastic. Plumbers seem to forget they even exist. So basically, a storage high performance combi is a combi but with storage at the back of it. And they work by charging. So a combi will do 12 litres a minute, unvented cylinder will do 20 litres a minute, and a high performance combi will do 18 to 20 litres a minute. And they really are good. So when you design a hot water system, 35 to 45 litres per person. And when it comes to designing a system, you have to think about the services, the demand. So this property in total is going to have about 3 showers. If you have a bar shower, they do 6 litres per minute. So a performance combi can handle that. Unvented cylinders, they're all good, but you've got to fit the cylinder, the system boiler, the controls, the motorised valves. There's 2 items to service. It's a space as well. So enjoy the video. High performance storage combis. So before I begin, I'm doing a tightness test. I want to check that the current pipework, existing pipework, has no leaks and it's not dropping. So I've increased the pipework diameter to 28 mil. This so the boiler can function efficiently. Expansion vessel's gone. Condensation pipe needs insulating because this is an unheated area, so it's classed as external. Should be at least 1 metre to 2 metres before any plastic or speed fit. Might put some extra supports in. So to get your warranty on the appliance and to get durability out of the product, the system's got to be flushed and cleansed. So I'll put a cleanser in the system. I now want to fill up and drain down 3 times just to get all that cleanser out. Because cleanser breaks down sludge, flux, and if you leave it in, it's a searching product and it will actually cause a leak, especially in the diverter valve. So yeah, I'm just draining down now. So I'm repiping, removing some of that speed fit. 2 rows of clips. There's going to be a magnet filter on it. There wasn't one before. Descaler. Put some extra supports in. The new flue is going to be clipped, bracketed, so it's nice and secure. It's all going to be screwed in. Socket there to meet regulations for the flue analyzer and lights. I've got the bracket in. It goes through the other side with extra supports. That's the low voltage charging pump, 24 volts. That's in the back unit where the 2 cylinders are to charge the water. At the top, it's all insulated. There's 2 cables. One's for the NTC of the cylinder and the other one is for the charging pump. They connect onto the PCB. There's the additional expansion vessel as well for the hot water. For the boiler, always activate comfort mode. That will charge the 2 cylinders at the back of the appliance, giving you 18 litres a minute. If you don't, it'll just function like an ordinary combi. So I'm done for the day. I'll put a cap on the gas supply. So there's an additional expansion vessel for the heating because there's a lot of radiators going on here. I've got to put a bracket on that yet and some strapping across it. filter. Filter goes in the return to protect the heat exchanger. The vessel goes in the return to protect the diaphragm. The neoprene diaphragm in that will have a better durability being on a colder return temperature. So the speed for elbows are hid there now. So it's a good metre across now. Gonna put some flooring across. All that will be hidden and look more presentable. When it's in the back of the boiler, it just circulates between them both. And the draw off, what's different about this, is here. How does the storage combi work? So, you have a preheated cylinder and a heated cylinder. You have a low voltage pump, but these are usually 24 volt. You have a heat leak and you have a combi. So, the water comes in, gets preheated to about 30-35 degrees, goes to a plate to plate where the water gets heated up, and this is the desired temperature storage. This could be 50 degrees. When the hot water isn't running, what happens is the low voltage pump will function and it will circulate and pre-charge the water, and it will circulate around through the plate to plate, around through the heat leak pipe into this area here. So you've got two cylinders prepared for the demand. So that's a 24 volt pump, small heat leak, pre-charged water, charged water, and this is where the water comes out, desired temperature. And this is how they get 18 to 20 litres per minute. 24 volt pump, and here you'll have an NTC and an NTC to monitor it. So it comes in, preheated, heated again, stored. When it's not being used, it's circulating round. Pressure release valve, condensation pipe, air gap there, look. Any issues, it will leak out the waste pipe, not the airflow. Discharge pipe here for the unvented cylinder. Lift it up, it comes out, so there's an air gap. It's neatly clipped to allow for expansion and weight. And it's solvent weld pipe as well. So when you cut cable, always just pierce the grommet in the boiler so it's airtight still. Only remove the sheathing enough to go inside the terminal connector. Look at this tool I've got. Lidl. It was like £4. Live neutral and earth. 240 switch live. 24 volt switch live. E-bus, which is low voltage, Morse code. Burner off, that's like for BMS systems or a sump pump, so it turns the system off. Centre of the pipe is 16 inches. 16 inches. Centre line of the projection. This is a mitre block. Nothing fancy. System's completely drained. Now I'm adding inhibitor. I want this to go right to the base of the system. This prevents against corrosion, electrolysis, helps lubricate, and this is to meet Part L specifications. How to improve performance of hot water. So here we've got a centralised hot water system. Perhaps it's a combi or a storage combi, or maybe even some form of unvented system. Here we've got a temperature mixing valve, incoming cold supply. So here we've got 20 degrees coming in, and this could be, let's say for example, 20 litres per minute, or perhaps even 14 litres per minute. Temperature 20 degrees, heated temperature here is 60 degrees. So this is a temperature mixing valve. And remember, on the incoming supplies you've got a single check valve, and you've got a filter, single check valve and filter. That's because this is a Cat 1 fluid category, and this is a Cat 2 fluid category, so they don't mix. So it's quite simple. Set this to say 45 degrees, and what you'll get is you'll get the cold water mixing with the hot water, and that will increase the flow rate. So 60, 20. Flow rate here can be increased and complemented by the flow rate from the incoming supply, and this will boost your hot water performance. Carried out a flow analyzer reading, parts per million were good, CO2 was good. Here I'm checking flue integrity because it's a vertical flue. The seals were lubricated, pipe was filed.